Have you ever pondered why understanding the fundamental principles of mathematics is so crucial? Welcome to the fascinating world of pure mathematics, a discipline that takes us beyond the practical, beyond the tangible, and into the realm of the abstract and theoretical. Here we delve into the intricate structures, concepts, and relationships that underpin the mathematical universe. Pure mathematics, in its essence, is the study of mathematics for its own sake. It's not about finding the quickest route to work or calculating the area of your garden. No, it's about exploring the very fabric of mathematical thought, untangling its complexities, and seeking to understand its fundamental principles. Imagine a painter who is not merely interested in creating beautiful portraits, but is driven by a desire to understand the nature of colors, the interaction of light and shadow, the essence of form and composition. That's what a pure mathematician does. They explore the abstract structures and concepts of mathematics, not necessarily for their immediate application, but for the sheer joy of understanding. Now you might ask, how does pure mathematics differ from applied mathematics? Well, while applied mathematics is about using mathematical principles to solve real-world problems, pure mathematics is about understanding these principles, regardless of their practical application. Think of it like this: applied mathematics is the architect who designs practical, functional buildings, whereas pure mathematics is the physicist who seeks to understand the fundamental properties of matter and energy that make those buildings possible. It's important to note that pure mathematics is not an isolated field. It's driven by intellectual curiosity and a profound desire to understand the fundamental principles of mathematics. It's like a voyage into the unknown, a journey driven by the quest for knowledge and understanding. So, what is the essence of pure mathematics? It's the exploration of abstract concepts, the pursuit of a deep understanding of mathematical structures, and the unraveling of the mysteries of the mathematical universe. It's about finding beauty in the abstract, celebrating the power of logical reasoning, and marveling at the elegance of mathematical proofs. In essence, pure mathematics is the pursuit of a deep understanding of mathematics, simply for the sake of knowledge itself. Now let's delve into the fascinating world of pure mathematics, starting with abstract algebra. Abstract algebra is like the philosopher of mathematics, engaging in deep contemplation about abstract algebraic structures. These structures, which include groups, rings, and fields, are studied for their inherent properties, often represented through abstract notations and symbols. It's like taking a magnifying glass to the essential DNA of mathematics, revealing the inner workings of its structure. Moving on, we enter the realm of topology. Picture this as the cartographer of mathematics, charting the terrain of topological spaces and exploring the relationships between points within these spaces. The focus here lies on somewhat elusive concepts such as continuity, limits, and compactness. It's like mapping out the landscape of a dream where the usual rules of geometry don't necessarily apply. Next, we venture into the world of differential geometry. This is the architect of mathematics, concerned with the geometry of curved spaces, like surfaces and manifolds. If you've ever marveled at the elegant curves of an architectural masterpiece, you've had a glimpse into the world of differential geometry, and while it might sound abstract, it plays a vital role in theoretical physics, particularly in the theory of relativity. Each of these realms of pure mathematics, from abstract algebra to differential geometry, is like an intricate tapestry, woven from the threads of abstract concepts and principles. They may seem separate, but they're all interconnected, forming the vast, multidimensional landscape of pure mathematics. So whether it's the abstract algebraist contemplating the nature of groups, rings, and fields, the topologist mapping out the topological spaces, or the differential geometer crafting the curves of manifolds, each is a vital part of the grand tapestry of pure mathematics. From abstract algebraic structures to the geometry of curved spaces, pure mathematics explores a myriad of intricate and abstract concepts. Join us as we continue our journey through the realms of pure mathematics, uncovering the beauty and complexity of this fascinating world. Continuing our journey into the realms of pure mathematics, we now move on to number theory. This fascinating area delves into the properties of integers and their relationships. It's like a treasure hunt with prime numbers, congruences, and Diophantine equations being the elusive jewels mathematicians strive to understand. Next, we venture into the realm of mathematical logic. This integral field investigates the structure of mathematical arguments and the rules governing mathematical inference. It's like the grammar of mathematics, setting the rules and structures that allow us to construct and understand mathematical sentences. And it's not just for the pure fun of it. Mathematical logic has profound applications in computer science, laying a solid foundation for algorithms and computations. As we continue our exploration, we encounter set theory. This intriguing area focuses on the properties of sets, those collections of distinct objects mathematicians so love to play with. Questions around the cardinality of sets, the existence of infinite sets, and the strange paradoxes that come with them, all fall within this realm. It's like a playground for the abstract mind, a place where the infinite can be tamed and understood. Finally, we reach the shores of category theory. This is an abstract language used to study the structure and relationships between different areas of mathematics. It's like the Rosetta Stone of mathematics, translating between different mathematical disciplines, revealing the underlying unity of mathematical structures. Category theory provides a unified way to understand connections between various mathematical topics, painting a holistic picture of the mathematical landscape. As we explore numbers, logic, sets, and categories, we come to appreciate the breadth and depth of pure mathematics. It's an intellectual odyssey, a journey into the abstract and theoretical, driven by curiosity and the desire to understand the fundamental principles of mathematics. It's about seeing patterns, making connections, and revealing the underlying structures that govern the mathematical universe. Through this exploration, we not only advance human knowledge, but also expand our intellectual horizons. Stay tuned as we continue our journey, exploring the impact of pure mathematics on our world and beyond. As we delve further into pure mathematics, we uncover the abstract study of mathematical analysis. Mathematical analysis is a cornerstone of pure mathematics in a realm where abstract concepts such as limits, continuity, and integration come into play. It's a world where the infinite and infinitesimal are explored, where the seemingly simple concept of a limit opens doors to the understanding of complex systems and structures. Imagine a line that infinitely approaches a point, but never quite gets there. This can be understood through the concept of a limit, which provides a way to capture the behavior of functions, sequences, and series at the edge of the infinite. Next, we have continuity. A function is continuous if it doesn't have any jumps, breaks, or holes. In other words, you can draw it without lifting your pen from the paper. The idea of continuity is fundamental in calculus, where it underpins the concepts of derivative and integral. Speaking of integrals, let's move on to the concept of integration, a central idea in mathematical analysis. Integration is the process of adding up an infinite number of infinitesimally small quantities. It's used to calculate areas, volumes, and a host of other things. It's the counterpoint to differentiation in calculus, providing a way to accumulate quantities over a range. These concepts, while abstract, have profound implications. They form the foundation of calculus, which has applications across physics, engineering, economics, and many other fields. And they're just a small part of the vast world of mathematical analysis, which also includes topics like differential equations, measure theory, and functional analysis. In the realm of mathematical analysis, we see the power of abstraction at work. By stepping away from the concrete and the specific, mathematicians have developed tools that can be applied in a wide range of contexts, revealing deep and fundamental truths about the world around us. Mathematical analysis brings us to the end of our tour through the realms of pure mathematics, a journey that has taken us from abstract algebra to the intricate concepts of analysis. So, we've explored the different areas of pure mathematics, but what impact does this field have on our world? Pure mathematics, a realm often considered distant and abstract, has an undeniable influence on our everyday lives. Its principles form the bedrock of many practical applications across various fields. From the algorithms that power our digital world, to the complex equations that assist in predicting weather patterns or modeling the spread of a disease, pure mathematics is a silent force shaping our reality. Consider the field of physics. Theoretical physics heavily relies on differential geometry, a branch of pure mathematics, to explore the mysteries of the universe. The theory of relativity, which drastically altered our understanding of time and space, wouldn't exist without the curved spaces studied in differential geometry. In the world of computer science, mathematical logic and set theory are essential tools. They help in the development of algorithms and data structures that form the backbone of software and internet technologies. Without these mathematical foundations, we wouldn't have the digital innovations we take for granted today. Even in economics, pure mathematics leaves its mark. Economists employ mathematical analysis to understand and predict market trends, enabling them to make informed decisions that influence economies worldwide. But the impact of pure mathematics extends beyond its practical applications. It contributes to the theoretical advancements that broaden our understanding of the world. Through the exploration of abstract concepts and structures, we delve into the essence of reality, unearthing truths that can be as beautiful as they are profound. Pure mathematics also fosters an intellectual culture of curiosity and discovery. It encourages us to question, to seek, and to explore, thereby expanding our intellectual horizons. This pursuit of knowledge often leads to surprising discoveries that, over time, may have unexpected practical applications. Indeed, pure mathematics, driven by the pursuit of knowledge, plays an essential role in expanding our intellectual horizons and advancing human understanding.